Let's talk about certificates, the digital ID cards of the internet, because without them your browser would basically be asking, who are you, and why should I trust you? Certificates are what allow secure websites, emails, and software downloads to prove they are legit and not secretly sketchy. Certificates are a core part of public key infrastructure, or PKI, which is the system of policies, procedures, hardware, software, and people use to create, manage, distribute, store, and revoke digital certificates. PKI is built on trust and is responsible for making sure digital certificates can reliably prove identity. Implementing PKI is complex because it must carefully manage certificates throughout their entire lifecycle, from creation to revocation. A digital certificate is a file that contains verifiable information proving an entity is who it claims to be. Certificate authorities, or CAs, are trusted organizations that issue and vouch for these certificates. A CA verifies identities in digitally signed certificates, and the entire trust model depends on the CA being trustworthy. To protect that trust, many organizations use an offline CA to safeguard the root certificate, only bringing it online when absolutely necessary. Registration authorities, or RAs, support the CA by verifying a user's identity before a certificate is issued. RAs do not issue certificates themselves, but they make sure the requester is legitimate before the CA signs anything. This separation helps reduce risk and improves the security of the certificate issuance process. Certificates sometimes need to be invalidated, and that's where revocation comes in. A certificate revocation list, or CRL, is a list of certificates that have been revoked and should no longer be trusted. Browsers and systems use the Online Certificate Status Protocol, or OCSP, to check whether a certificate is still valid or has been revoked, helping users avoid compromised or untrusted certificates. Certificates can also include digital certificate extensions, which are optional fields that define how a certificate can be used. These extensions specify purposes like digital signatures, key encipherment, data encipherment, certificate signing, and CRL signing. Extensions allow one certificate to securely support multiple cryptographic functions without confusion. A digital certificate combines a public key with a digital signature from a trusted third party. To obtain one, an organization generates a key pair and submits the public key in a certificate signing request, or CSR, to a CA. Self-signed certificates can also be created for internal use, where trust is managed within an organization instead of relying on an external CA. Several certificate fields help identify and expand how certificates work. The common name, or CN, identifies the certificate owner, while subject alternative names, or SYNs, allow multiple domain names or services to be protected by a single certificate. Certificates also have a defined validity period with a start date and an expiration date. At the top of the trust chain is the root certificate, which belongs to the root certificate authority. Everything in PKI starts with the root of trust, and if a root certificate is compromised, the entire system is at risk. Because of this, root CAs are protected with the highest level of security and are often kept offline. There are different types of SSL certificates used on websites. Domain validation certificates confirm control over a domain, while extended validation certificates require additional checks and display the organization's name to users. SYN certificates protect multiple domains, and wildcard certificates secure all subdomains under a single domain name. Organizations sometimes create their own self-signed certificates for internal systems instead of purchasing third-party certificates. This works well for internal websites, email systems, or applications where all users trust the internal CA. Certificates are also used for email encryption and digital signatures, ensuring integrity, authenticity, and non-repudiation, and for code signing, which verifies that software has not been altered before installation. The key takeaway is that certificates establish trust, verify identity, and protect data across websites, emails, and software using PKI. If this helped, consider liking and subscribing for more lessons like this.